Okay, so I'm showing you page 84 in your textbook. This is a summary of everything that we did just a minute ago. And this is maybe a nicer, prettier table. But if you're doing it by hand, and by the way, I really don't ever ask you to do it by hand. I am going to show you how to do it on StatCrunch. But I did need to talk to you to kind of make you understand what it is. As long as you have an understanding of what, what the standard deviation and what the variance is, then I don't mind so much you using something to calculate it. Okay. So these are all the steps. You should be able to read this right here. If you can't read this, then you're kind of missing the big picture. And all of it is modeled down here. So the first thing it says, find, what does that say? Find the mean. So you know how to find the mean. You add them all up and divide by how many there are. You add all these up, 450, divide by the fact that there's 10 of them, and you get that the mean is 41.5. Then it says subtract each data entry from the mean. We're finding out how far away are you from the average. So this one was just half, this one was 3.5, this one was 2.5. Remember what happens when we add all these positive and negative numbers up? It doesn't add up to give us a total sum of differences. So we kind of trick it for a minute. We square these numbers so that we can get rid of the negatives. Then we add up the squares. This is the sum of the squares. That's what that SS means. The sum of the squares. We add up the sum of the squares. And then we divide by how many we had, and that's our variance. But remember, what we're really interested in is the average distance. So in order to find the average distance, or the average difference, is we want to take the square root of that. And then that came out to be, we divided it out and it was 2.97. So they rounded it up to 3. Okay, so anyway, this is what all of that says. This is finding the variance. That's after we take, this is finding the difference. This is squaring the difference. Oh, this is finding the difference. This is squaring them all. This is adding them all up right here. This is taking that sum and dividing it by how many we have. And then this last step is just taking the square root. Okay, I do want you, remember this is a parameter because all of this was for a population. Do you see that word right there? Population. That means that, we're working with the population, the entire body of some, I don't know, whatever it is we are talking to or gathering data on. So all of these numbers right here are parameters because they concern the population. If you go to the next page, on page 86, it starts showing you how to do all of this for a sample. Okay, so what if our data is data from a sample, not from a population? And man, my pages really turn slow when I'm recording. So anyway, there's a slight bit of difference. Okay, first of all, this is a typo. Do y'all see the typo? The typo is right here. That's not a capital letter N. It should be lowercase letter n, and we learned that in section 3. I believe section 3 was oh shoot, I forgot to change to my pointer. I think section 3 was on page 67 for the sample data. Is it going? Yeah. You'll have to ignore that in just a second until I get back to page 85. On page 67, right there, see, for the sample mean, you find X bar. X bar is the sum of the data divided by the sample size, not the population size. So on page 85, there is a typo. So you still find the average, okay? You find the mean. You're dealing with the sample data. You still find the mean. You do that the same. You find the mean. You find the differences between the numbers in the data set and the mean. You still square those differences. You still find the sum of the squares. And the only thing that changes is right here. I don't know why it's not letting me highlight. But the only thing that changes is right here. In when we were dealing with, I can click over here. When we were dealing with the population, we divided by the total number in the population. But when we're dealing with the sample, we divide by the sample size minus 1. Do you want an explanation for that? You have to take a higher level statistics course. There is an explanation. It has to do with degrees of freedom, and that's above my pay grade. So all I do is just accept that somebody smarter than me figured out that that's what we need to do to adjust for the fact that we're dealing with the sample and not a population. And I said, okay, yes, sir, I'm going to do that. So anyway, I don't really have an explanation. It is above my level of understanding. So this is the difference between population and sample, is you divide by n minus 1, and in population, you divide by the population, the total set. Okay, so there is an example problem on the worksheet that is over here for you to do. And I also, I fixed that. So on this is what I think it's on page 85. Sorry, this is on page 85. There was a typo. Oh, good Lord, that's terrible. Okay, so on page 85, there is a typo, so I fixed it, but the process is the same. Be sure you recognize the symbols. For variance, they use the lowercase sigma. For population, they use a lowercase s. And just for writing purposes, I'm not going to write my s's like that, because if I write my s's like that, it's going to look like a 5. So I'm going to write my s's like that. And for those of you millennials who didn't learn how to write cursive, that is a lowercase cursive letter s. So I'm going to do s and s squared like that. So you can, I don't confuse them with my 5s. Okay, this is mean. Mu is the mean. X bar is the mean for the sample. Mu is the mean for the population. This is the deviation. It's the difference between the data point and the mean. The data point and the mean of the population, the mean of the sample. And this is the sum of the differences squared, the sum of the differences squared, sum of squares. So just be careful with this notation, okay? And then instead of doing this one by hand, which I strongly suggest you do, following this, okay, it should look very much just like this. All right, I strongly suggest that you do that. If you want to check your work, you can take a picture of it and send it to me, and I'll tell you if I agree or disagree. You're welcome to do that. I am going to jump over to StatCrunch, because StatCrunch is going to be extremely confusing if you're not paying very, very, very close attention to me right now. Okay, so if you'll notice, I have put the first set of data that we worked. Okay, I have placed, let me make sure you understand, I'm looking at this set of data right here, and I'm going to show you how to do variance and standard deviation on StatCrunch. So I'm looking at that set of data. So I've got it in. I'm going to go to Stat. I'm going to go to Summary Stats. I'm going to go over to Column. I'm going to pick the column that I'm looking for, and I'm going to start by doing variance. By the way, you can do 2 things at once. It says right here, if you see mine in yellow, it says select more than one with shift click or control click. I believe I have to do control. If you do shift and you pick like, well, let me show you. If you do N, and then let's say I wanted to do the sample size, and I wanted to do a standard deviation, and I pick shift, it picks all of them in between. And if that's not what I wanted, if I really just wanted, let's say, mean and standard deviation, and I pick control, it'll just click the two that I clicked and leave the one in between out. Okay, so what I really want is variance and standard deviation. Now remember, we've calculated this by hand, and the book did it by hand, and it agreed with this. And so if I pick variance and standard deviation for this set of data and I compute, I do not get the same values that we got by hand. Because remember, we got 8.85 for the variance and 2.97 for the standard deviation. Let me explain to you why. This is very important. Because most statistics is sample statistics. It is really, really, really difficult to work with populations. Populations are better to work with because populations are able to be more predictive because they're bigger pieces of data. But when you deal with populations, you're generally dealing with thousands, if not hundreds of thousands of data. I mean, think about the difference between, surveying all women in Fort Worth versus surveying all women in the world. Okay, so it's a vast difference. And so that's why most statistics is sample statistics, because we are very seldom are we going to be dealing with an entire population. Now, for purposes of this class, we do have lots of examples of population data, but because most statistics is dealing with the sample, when we do stat and we go to summary statistics and we tell it that we want to do variance and standard deviation, this is defaulting to sample variance and sample standard deviation. If you want population, you have to go down here where it says unadjusted variance and unadjusted standard deviation. So I'm going to pick this one. I'm going to hit the shift key and I'm going to pick that one. And since we used the population formulas when we did that first example, unadjusted means population. We adjust our formula for sample, so unadjusted means it's population. Okay, so I'm going to press compute. And now with the new thing, we get 8.85 and 2.97, which is the exact same thing that we got here, 8.85, 2.97. So be sure you know for populations, let me write this. This camera is not, oh goodness. Okay, for populations, on StatCrunch, be sure to use UNADJ, unadjusted variance, and unadjusted ADJ standard deviation. And I don't know if they wrote it all the way out or not, but be sure you use, oh, the whole thing turned. Be sure for StatCrunch, be sure for populations, you use unadjusted variance and unadjusted standard deviation. So I'm going to stop the video because I'm at 13 minutes and I really like to keep them around 8, so I'm over. But what I'd like for you to do, I will start my next video making sure, now this one is a sample. This is a sample. This is an example of a sample. Because how do I know it's a sample? In a study of high school football players that suffered concussions. Is it all high school football players? No, it's just a few. And which few is it? The ones that suffered concussions. So this is how I know it's a sample, because it's just a portion. It tells you which one, which portion. This is just a portion of football players. Okay, this is a sample, so that's how I read that and know that it's a sample. So this is what you can do it by hand. I don't know if I have it worked out done by hand, but I will also I will compare the StatCrunch answers that you get if you use, and this one, remember, for sample, you just on StatCrunch you just use variance, and variance is S squared, and then standard deviation is S. Okay, so you just pick variance and standard deviation on StatCrunch, and then it'll give you that. Okay, I'll start here with my next video.